Hi everyone, my name is Evanthia Hatziminaoglou. I am a faculty astronomer at ISO in Garching, currently on research period at the ISE in Tenerife. And I have been leading the AtLAST operations work package already since phase one, so for the past 4 years now. And in fact, I would like to use this opportunity. It won't be much of a presentation, it's just to touch upon a few points, but I want to use this as an opportunity to start a discussion on some of the aspects of AtLAST operations and the way this future facility could revolutionize not only science, but also the way we operate such facilities. So currently, most large astronomical facilities on Earth operate either at the site or very near the site, in what we divide between visitor and service mode, visitor being the astronomer going there and observing, and services being taken care of by the observatory of the facility itself. A good example of remote operations is ALMA, where since shortly after the onset of the pandemic, part of the science operations moved from the operation support facility at 3,000 meters down to Santiago, about 2 hours flight from the facility, where the morning and day shifts are carried out from, and the night shifts are still operated from 3,000 meters, which is almost on site, not quite, it's about an hour's drive. Remote means in this case, so we're not at the telescope, we are near the telescope or far from the telescope. Anyway, we're still in the same country, same time zone. Example of distributed operations, we don't really have many right now, but we have what it's a good approximation is what was happening with the lunar planetary missions that were being tracked by the Earth, and as the Earth rotating, the tracking station that was operating at any given moment was changing. But in any case, operations models currently, regardless of the facility being small or large, new or old, largely follow long-established procedures. And by long-established, sometimes we're talking about things that were established half a century ago. So when we talk about operations, it's not only data acquisition. The operations start from the site preparation before the construction, moves on to construction. From there, we go through the phase of assembly, integration, and verification. From there, we go to commissioning, then to science verification, then to early science, and full operation. So all of this is encompassed within what we call telescope operation. And in fact, many times the block of commissioning, science verification, early science, and full operation repeats itself when new instruments, for example, are integrated or upgrades are happening. So AtLAST is going to be a facility of the future. If all goes well, it will be built in the next decade with a plan to operate for hopefully about 50 years. So we're talking about operations up until the 2080s. This means currently, when we are developing the telescope operation, there are many, many unknowns. There are more unknowns than there are knowns. At the same time, we need to build something very robust, despite all of the unknowns, that also is sustainable in the long run with every possible interpretation of the word sustainability. Now, this telescope, this facility is going to operate under very different geopolitical conditions and other conditions than the ones that we are accustomed currently and the ones that we're used to in the past couple of decades. First of all, we see that the science funding is being affected globally. Operations funding is always affected because operations are always on the second level when the funding is being discussed. So usually facilities run with limited operational funding, but this is going to suffer even more in the future. The geopolitical stability that we took for granted, fortunately, for the past few decades is no longer perhaps guaranteed, and we don't know how things will look half a century down the road. Environmental considerations are becoming more and more important in all aspects of our lives, and accessibility and working conditions are more and more taken into account when talking about any kind of on working places. At the same time, technology what we call now AI, but it will take different flavors, different names. It will evolve in different ways. Will have evolved in ways, in fact, that we cannot foresee right now. At least I can't foresee right now. Science at the same time is also evolving very, very quickly. And at that time, when AtLAST starts operations and maybe a couple of decades down the road, it will be the default will be multi-something. Something being a wavelength, will be messenger, will be facility, will be instrument, it will be multi-whatever. And this will be the norm, which means the science priorities will also be different from now. They will be continuously changing. And the discoveries from the new facilities will be what will be driving these new ways of doing science. And therefore, if we are to offer user support, we also have to customize the user support a motor facility offers to its user base. So within the AtLAST operations work package, we are addressing three big topics. The first one is the novel operations concepts. The second one is data infrastructure, data archiving, and user access. And the third one is investigation of possible user support models. And what I want to focus the discussion today is number 1 and 3. Number 2 is hugely important, but it touches upon many aspects of initiatives that are currently being developed in Europe, and this will definitely be the topic of some other discussions. So I want to focus on 1 and 3. So what we mean by modern operation concepts, I think you already realize that we're talking about remote distributed operations. Now, to clarify, remote and distributed is not the same thing. Remote means we're not very close to the facility. Distributed means operations are not happening from one place alone. So we're talking about various operation support centers spread all over the globe. Now, for a submillimeter facility that will be working 24/7, if we want to also adhere to modern work policies and everything else that we spoke about, ideally, we need 4 or at least a minimum of 3 locations around the globe to be able to cover 24/7 or more or less normal working hours, some special arrangements for weekend holidays. Anyway, these are details, really. The important thing is that we can cover the operations from different parts of the world, which means that there will have to be live connection and communication 24/7 with the site, among the operation centers, with the telescope itself, and all possible permutations. And AI at that time will inevitably be an integral part of operations and maintenance. Now, it is obvious that we will not be able to do this from day one. Remember what telescope operations means. It means all these suites of events and phases. So the idea will be, of course, that we start with a hybrid model during the first phases or the first years or during commissioning. However, the whole of the infrastructure has to be in place by the time we start with AtLAST. So we will go slowly from a hybrid model where a big part of the operations will probably be carried out at the proximity of the telecom, not exactly at 5,000 meters, but around there, and then little by little move bigger and bigger chunks to the other locations all over the world. Another thing I want to bring up now is the redefinition of dynamical scheduling in the widest possible way. So we are going to be dealing with the usual type of proposals, regular proposal like program, COO, direct discretionary time, cross-cycle proposals, yes. We're also going to have, of course, joint proposals with big facilities, current and future, like ALMA, EHT, SKA, Rubin, you name it. But we also have to be able to respond to alerts from other facilities. We are thinking of establishing observatory, where observatory here means community projects. We will be multi-cycle projects proposed by the community covering overarching science cases. Large-scale galactic and extragalactic surveys that may or may not be the same as the observatory project. Monitoring projects that require repeated observations at random or set cadence, again, that may or may not overlap with the ones above. Filler projects to make sure that the telescope will not be able at any given time. And a new thing, which is a parallel lane that will allow for a continuous influx of proposals in parallel with a set yearly, perhaps proposal submission deadlines to account for student proposals, proof of concepts, and the like. So this means that the dynamic scheduling has to be really, really dynamic and change constantly, continuously to adapt not only to weather conditions, but to all this influx of information from other facilities, from new proposals, etc. Finally, when we talk about user support models, I'm not going to read this slide. The only nice thing here is this nice acronym I came up with. But we will have to support our users the same way that Alma did, in fact, from the very beginning, in the way that the facility is available for everybody, not only for the experts. Okay, and to do that, we need to grow the base. We have to continuously provide what the users need, the needs of the users we need. As we said, it will become multi-whatever, so we have to adapt the science, the support we provide to the multi-whatever science. And this will have to mean a continuous investment in user support practices for the duration of the operations of the telescope. So in order for us to assess already now what the projected needs of the community are right now, we are planning on actually running a user survey in 2026, about in a year's time from now, to collect ideas and projected needs. And I think this is my last slide, so one but last. So I would like again to discuss with you the implications, challenges, and benefits of those remote distributed operations, the kind of proposal type and proposal science that we're going to be doing, and the customization of the user support, keeping in mind that one of the biggest obstacles may not be technological after all. It might be very, very human, and it is the fear of change, because we have been operating large facilities in a specific way for a very long time. So we have to take the leap of faith, and we have to dare to travel off the beaten track. And with that, I will stop here.